So good morning students. Today we are going to see topic on molecular rearrangement. In this molecular rearrangements we are going to pinocol-pinoclone rearrangement. So what is meant by pinocol-pinoclone rearrangement? Here the conversion of 1,2 diol into a carbonyl compound in the presence of an acid catalyst with change in carbon skeleton. See here, I am taking example as 2,3 dimethyl butane 2,3 diol. Here, in the presence of acid, what happened? This diol change into a different carbon skeleton carbonyl compound. That is pinacolone. 2,3 dimethyl butane 2,3 diol in the presence of acid convert into a 3,3 dimethyl butanol as a product, different carbon skeleton in the presence of an acid catalyst. We call this a rearrangement as an pinocol-pinoclone rearrangement. 1 to shift, 1 to shift, that is white mode shift. When come to the mechanism, so in the presence of acid, what happened? The OH group, it has the non-bond electron, will abstract a proton from acid and become an OH2 cation. This OH2 cation is unstable molecule, so it loses its water molecule to form a carbocation 1. So to stabilize this carbocation, the methyl group going to migrate from the first position to the second position. So methyl group migrate from first carbon to the second carbocation. The first carbon became an carbocations. To stabilize this carbocation, the oxygen will give its non-bond electron to the carbon. So the oxygen became an oxygen cations. This oxygen cation to stabilize, what happened? The hydrogen ions will undergo deprotonations to form a carbonyl containing compound, that is pinocolone. So 1,2 diol to a carbonyl containing compound, different carbon skeletons. We call this rearrangement as an pinocol-pinoclone rearrangement. That is 4 steps is happening. First step is protonation of hydroxyl group. Second step is loss of water molecule. Third step is migration of methyl group. So these methyl groups form a resonance stabilized carbocation 1, 2, 3. When compared to 1 and 3, 3 is the most stable carbocation. Why? Means it has a complete octet structures when compared to the first carbocations. This 3 will undergo deprotonations to form a carbonyl containing compound, that is pinocolone. So that's why the mechanism for pinocol-pinoclone rearrangements. So some of the examples we are going to. So what I have told in the part, that was the theory I am given here. What it means, in carbocation 1, carbon has incomplete octet, but in the cation 3, every atom has a complete octet. That's why the 3 is more stable than 1. Thus, the stabilized driving force for this rearrangement. So, from this we know that phenyl group have more migrating aptitude when compared to hydrogen. Then, so here the phenyl group will have more migrating aptitude to form a aldehyde containing compound, dialdehyde containing compound, diphenyl containing aldehyde. That's why phenyl group move first because of the greater chance of stabilizations due to delocalizations. So carbocation, the most stable carbocation as phenyl containing carbocation is most stable. That's why phenyl has the more migrating power when compared to hydrogen. So these are some examples of migrating aptitude. I am giving the example, the diol attached with one electron donating group, one aromatic group. Also, second position, one electron donating group, ED electron donating group, another one is aromatic group. Here EDG, this one aromatic. Okay, which one will be more preferred? So migrating aptitude when compared to migrating aptitude, electron donating containing aromatic compound will be more preferred when compared to aromatic ring. That's why the methoxy, that is electron donating, are more preferred carbocation. That's why it has more migrating aptitude when compared to the phenyl group. The second one, the diol attached with the phenyl and methyl. So this one symmetrical molecule, which will have the more migrating aptitude. We already know that aromatic compound, aromatic group have more migrating aptitude when compared to methyls, that when containing diphenyl carbonyl compound. Likewise, methyl hydrogen, which will be more migrating aptitude? Hydrogen will be more migrating aptitude when compared to the methyls. That's why I'm getting carbonyl compound. Okay, butanol compound. Here another one examples, which group migrate? Here see one aromatic group, another one is electron donating group. From here we know that electron donating group will more migrating power when compared to the aromatic compound. That's why I am getting quinaclone as an electron donating carbocations have more stabilized carbocation when compared to phenyl carbocation. That's why electron donating quinaclone will have the major products. Another one examples I am given here. One is electron donating group. This one is electron donating group. This one is electron withdrawing group. This one is phenyl group. Which one will have the more migrating aptitude? So here we already know that electron donating group will have more migrating aptitude compared to phenyl and then electron withdrawing group. So here the phenyl group have more migrating aptitude than electron withdrawing groups. That's why the phenyl containing carbocation more stable. So I am getting a product as a nitro containing carbonyl compound. Here the second example. So here both are electron withdrawing group, but the position is here the nitro is in the para position, whereas here the benzene aromatic nitro in the meta position. So which one is more preferred, para or meta? We know that the electron meta position will be more preferred when compared to the para position of electron withdrawing group. That's why meta containing nitro position will more preferred. That's why the meta containing nitro group is a major product. Whereas in the case of unsymmetrical diol, see here in case of unsymmetrical diol, which one will have the major product? Here we have to see which carbocation is the most stable carbocation. See here the dimethyl diphenyl. Okay, so this carbocation, methyl containing carbocation is less stable when compared to diphenyl carbocation. So that's why diphenyl carbocation is more stable. The more preferred product is the diphenyl containing carbonyl compound. So this series cannot be applied in unsymmetrical quinaclone substrate, where the formation of more stable carbocation control the reaction pathway. Okay. With unsymmetrical quinacoles, the group migration is largely determined by a combination of factors such as carbocation stability and relative migrating aptitude of the substance. So that's why the most stable carbocation will form the major product. Thank you.